With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given that there is a high tension wire which is at a high potential with respect to the wire which is well grounded called the earth wire. Now, you must have seen such wire stretched parallel to the road. There is a high tension wire between point A and B 1 kilometer apart. Now, the distance between high tension wire and the earth is 1 meter. The resistance of the high tension wire is 1 ohm per meter. This wire is at a potential of 1100 kilovolt. 11 kilovolt. That means 11,000 volts. Now at a point A with respect to the earth, and is carrying a current of 1 ampere which returns back to the generator by which through the earth wire. Now this wire is quite thick wire where there is a signboard at the pole over which the wire is stretched reading danger. You might think that what would happen if one touched this wire. Will one feel a shock or not? Well, it depends on whether the current through the our body exceed in a particular value which is called to be the critical current. Now the question starts from here. So this is the general information which has been given with the wire which have been seen. So the high tension wire. Now the question is, why is high tension wire thick wire? We need to select the most appropriate option. So for example, if we take two wires, if we just draw two wires. So let's say this is one of the wire and this is another wire. So let's say this is a thin wire and this is a thick wire of the same length. Okay. So let's say the length is L, the length is L. Now this would be a circular cross section. So here the cross section would be circular. Okay, the cross section would be circular like this. Now let's say the resistivity, basically they would be same. Resistivity is the property of material. If we have not changed the material, so resistivity would change. Now here the area is, let's say A, and here let's say the area is A dash. Now if the area is greater, what will happen? So for example, if we calculate the resistance for the first part, we know that R would be equals to rho L divided by A. Now, if we increase the area of cross section, what will happen? Resistance would be decreased. What is the benefit of decreasing resistance? So, for example, if we are supplying a current, let's say the current which is going through this is I. Okay, current which is going through this is I through the wire, thick wire, or we can say that thin wire. So we say that what is the heat which is generated? We know that H would be equals to I square RT. I square RT. Now, for a given amount of current, for a given amount of time, if we increase the value of the resistance, what will happen? If R get increased, then heat lost would get increased. On the other side, if we reduce the value of the resistance, then heat loss would be decreased. So why we pick up a greater cross section wire? So that resistance is decreased, so that the heat which is lost is decreased. So which is the correct option? The correct option would be so that more current may flow. This is wrong. So that resistance may be less, thereby reducing power loss in the transmission line. So basically, when we know the heat loss, we can calculate what is the power loss. Why? Because the power loss would be equals to H divided by T. So it would be simply I square R. So if R is reduced, then power loss would be automatically reduced. So the B option is the correct option. Now if we check the C option, so that it bear higher tension and therefore sag less. No, this is not connected with the this end. So it is only connected with the power loss. So that when it further population increases, the existing wire may serve the purpose. This is also wrong because we can always extend the supply. So the correct option would be the B option. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.